Your Azure VM still will not connect. You check the IP address, you check the port, you maybe even changed a firewall rule. But in Azure, the same failed connection can be caused by two completely different decisions. One decision is, where should this packet go next? The other decision is this packet allowed to go there? If you mix those up, you can spend an hour changing the wrong thing. So in this lesson, we're going to separate route tables from network security groups using one memory anchor. Route table decides where, NSG decides whether. Think of a packet leaving a virtual machine. Before it can be allowed or denied by the right control, Azure has to know the next hop. Is this traffic staying inside the virtual network? Is it going to the internet? Is it being forced through a firewall or network virtual appliance by a user-defined route? That is the routing question. A route table plus Azure System Routes answers, where does this packet go next? An NSG answers a different question. It checks direction, source, destination, protocol, port, and rule priority. If the rule says deny, the packet can have a perfectly valid route and still be stopped. That is the permission question. Route table, where, NSG, whether. Let's start with routing. Azure creates system routes automatically for a subnet. That is why resources in the same virtual network can usually communicate, and why outbound internet paths can exist without you creating a route on day one. But administrators can add user-defined routes. These are the routes that often show up in real troubleshooting. Maybe your organization sends outbound traffic through Azure Firewall. Maybe a subnet sends traffic through a network virtual appliance. Maybe a route points to a virtual network gateway. The key is that a route does not say, allow this app on port 443. A route says, for this destination prefix, send the packet to this next hop. So if a VM cannot connect, one route table failure mode is simple. The packet is being sent to the wrong next hop. The packet is not blocked at the gate. It took the wrong road. Now compare that to a network security group. An NSG can be associated with a subnet, with a network interface, or both. It contains security rules with priorities. Each rule has a direction, inbound or outbound. Each rule has matching fields, source, destination, protocol, port, and action. And each rule has a priority. So the lower priority number is evaluated before higher priority numbers. That means an NSG is not choosing the road, it is acting like a gate. The packet may know exactly where it should go, but the gate can still say no. If outbound 443 is denied, your VM may have a route to the internet, but HTTPS still fails. If inbound 3389 is denied, your RDP path may route correctly, but the inbound connection is still blocked. So when you troubleshoot, use a two-step order. First, can it route? Check the next hop. Check effective routes. Ask what Azure thinks the path should be. Second, is it allowed? Check effective security rules. Check whether the matching NSG rule allows the protocol, port, direction, source, and destination. This order matters because it keeps you from chasing symptoms. If the next hop is wrong, adding an NSG allow rule will not fix the path. If the next hop is right, but the NSG denies the port, changing the route table will not open the gate. Here is a practical example. A VM in a spoke subnet needs to reach an internal application. The admin expects the packet to stay inside the virtual network path, but there is a user-defined route on the subnet. For that destination range, the next hop points to a firewall or network virtual appliance. If that appliance is not configured to forward the traffic, or if the path is incomplete, the VM connection fails. In this case, the first question is not which NSG rule blocks the port. The first question is, where did Azure send the packet? If Network Watcher next hop shows the appliance as the next hop, then routing is your lead suspect. You might need to fix the UDR, fix the appliance forwarding path, or fix the return path. Do not start by opening every NSG rule. The packet is on the wrong road. Now flip the scenario. A VM needs to reach a web app endpoint over TCP 443. The next hop is correct. The route is valid. The packet is going where you expect. But the subnet, or NIC, has an NSG with a deny rule that matches outbound TCP 443, or an inbound rule blocks the return side scenario you are testing. Now, the route table is not the problem. The packet reaches the security decision point and the gate says no. This is where effective security rules matter. You are looking for the exact rule that matched: direction, priority, source, destination, protocol, and port. The fix is not add another route. The fix is to create or adjust the right allow rule at the right scope with the right priority without opening more access than the requirement needs. For AZ-104 and for real administration, remember the checklist. If the scenario says traffic goes through the wrong appliance, wrong gateway, or wrong next hop, think routing. If the scenario says traffic reaches the right subnet or service, but a port, protocol, source, destination, or direction is blocked, think NSG. Use the tools in that same order. Next hop tells you where Azure is sending the packet. Effective routes show the route decision for the NIC. Effective security rules show whether the NSG allows or denies the traffic. Route table decides where, NSG decides whether. That is the mental model. If you want the 60-second version of this model, watch the NSG versus route table short linked in the description. And if you are studying for AZ-104, keep practicing this as an admin troubleshooting habit. Trace the packet first, then find the decision that stopped it. Thanks for watching WebLizard Cert Lab, Microsoft certification prep, and Azure admin troubleshooting without dumps.